Hello students, I hope you all must have remembered this table. In this table you have learned the values of trigonometric ratios at 5 very important angles. Now children, we will continue with this table only. Let's let let us observe something very important reflected in it. Just see children, the value of sine 30 degree and the value of cos 60 degree. So you have seen whatever is the value of sine 30 degree, same is repeated at cos 60 degree. Just see the sum of 30 and 60. So these two angles, they are complementary to each other. Now let's observe one more value. At sine 45, whatever value you are having, the same is repeated at cos 45. What is the complementary of 45? 45 itself. Now see, whatever is the value of sine theta at 0 degree, the same value cos theta is having at 90 degree. And this 0 degree and 90 degree are again complementary to each other. So children, with this observation, we are able to conclude that sine theta, whatever is the value of sine theta, is equal to cos 90 minus theta. Let's observe it with this example. If suppose I am saying that sine 30 degree is equal to 1 by 2. So children, you have seen that 1 by 2 is the value of cos 60 degree. If suppose I say that I am assuming 30 degree as theta, so that means I can write cos 60 degree as cos 90 minus 30, or I can write cos 90 minus theta. So the two angles are complementary to each other, 30 and 60. They are complementary to each other. So that means this 60 can be written as 90 minus 30. And if I assume 30 as theta, it can be written as cos 90 minus theta. Similarly, whatever is the value, and it is valid vice versa. That means if you are observing the value of cos 30 degree, the same value you will be getting at sine 60 degree. So I may say that cos theta is equal to sine 90 minus theta. Now children, similarly, whatever is the value of tan theta, tan 30 degree, the same is repeated at cot 60 degree. Tan 30 degree is repeated at cot 30 degree. So I can say that tan theta is equal to cot 90 minus theta, or it can be written in the reverse direction also. So it can be cot theta is equal to tan 90 minus theta. Secant theta, secant 30 degrees to the same value you will get at sec 60 degree. Cosec at 30, sec at 60. So they are complementary to each other. Therefore, another formula, cosec theta is equal to sec 90 minus theta, or sec theta is equal to cosec 90 minus theta. I hope you are able to understand how come we are able to write all these things? And these formulas are known as complementary angles. The value of T ratios at complementary angles. So at complementary angle, the value of sine theta and cos theta are same. The value of tan theta and cot theta are same. Cosec theta and sec theta are same. Now let's do some questions to understand the application of these complementary angle formula. So these are known as trigonometric ratios of complementary angles, or we can say these are the formula including complementary angle. Trigonometric ratios of complementary angles. These are trigonometric ratios at complementary angles. Now let's understand their application. To understand the application, we will solve the questions of exercise 8.3. Let's do exercise 8.3. Question number question number 1. And according to this, we have to evaluate sine 18 degrees upon cos 72 degrees. Children, first of all, you will observe the values given here. The values given here, the angles given are 18 degree and 72 degree. Just notice the sum of these two angles. Are they complementary angle? Yes, they are. Their sum is equal to 90 degree. So if it is so, if you are able to observe this thing, that the angles attached to these two are complementary angle, then children, you have to decide one out of the two given trigonometric ratios. That means either you will apply the formula here or you will apply the formula here. Suppose I am taking sine 18 degree and I want to change this by applying the formula. Suppose I am applying the formula here. So I will read this 18 degree as theta. So now I will read it as sine theta, and the identity that I have told you for complementary angle, sine theta is equal to cos 90 minus theta, and theta we have supposed is equal to 18 degree. So if I want to write theta, I have to write 18 degree, and then the denominator will remain the same because I have to change one among the two trigonometric ratios including complementary angles. So these two trigonometric ratios have complementary angles attached to it. So I will change only one out of two. So first I will change the formula. I will apply the formula sine theta is equal to cos 90 minus theta. In first step, I will apply the formula. And in the second step, I will simply do the subtractions. So when I subtract 90 minus 18, it will be cos 72 degree. And in the denominator, I am also having cos 72 degree. So these two will cancel each other. And the answer is 1. Let's do few more examples to understand better. Now this is question number 1, and this is the third part. Question number 1, this is the third part. And here it is cos 48 degrees minus sine 42 degree. Again, just see the angles attached to them. The angles attached to them are again complementary angles. So whenever the angles are complementary, I will decide that I will change one among the two. So either I can change this or I can change this. Suppose I am keeping this cos 48 as it is and changing this sine 42 degree. So I will read 42 as theta. So this is sine theta. If I apply the formula, I will write in place of sine theta is equal to sine theta is equal to cos 90 minus theta. So children, I'll change the style of writing sine 42 degrees. I will write it as sine theta is now will become cos 90 minus theta, and I'm assuming theta as 42 degree. So in place of theta, I'll be writing 42. In first step, I will apply the formula, and in the next step, I will just subtract and write down the value. So this will become cos 48 degree. So cos 48 subtracted from cos 48 will give us 0. So I hope you are able to understand it. Now next, let's do question number 2. Question number 2. In question number 2, we are given, show that first part we will do, this is 1048 degrees into 1023 degrees into 1042 degrees into 1060 degree 67 degrees is equal to 1. Let's start solving from left hand side. And if I am solving from left hand side, I first will observe which trigonometric ratios are containing complementary angles. So 48 and 42, they are complementary. 23 and 67, they are complementary. So as you know, then in multiplication, there is no difference if I will write 1042 just next to 1048. As in multiplication, there is no effect of changing the order. So I can write the question like this: 1048 degree, then I'll write 1042 degree, and the reason is these two are having complementary angles attached to them. Then this is 1067 degrees. I've taken left hand side to simplify. Now, among these two angles which are having complementary angles attached to them, I will change one only. So if suppose I decide that I will change this, then the angle attached to this will be treated as theta. So I will read it as 10 theta. If this is 10 theta, that means the formula that we have is 10 theta is equal to cot 90 minus theta. So children, 10 theta can be replaced by cot 90 minus theta, and in place of this theta I will write its value, that is 48 degrees. So I will change it and write 48 degrees. This I will copy as it is because I have to change one out of the two complementary angles. Now these two again are complementary, so I will change one among them. So suppose this time I'm taking this as theta, so I'll write it as 10 theta is equal to cot 90 minus theta. Since I have changed this one, so I have to copy the next one as it is, 1067 degree. So in this step, we have just applied the formula. In the next step, we will just subtract. So it will become cot 42 degree into 10 42 degrees. Then again cot 67 degrees and 10 67 degree. If you remember, 10 theta is perpendicular upon base and cot theta is base upon perpendicular. So I can say that 10 theta is equal to 1 upon cot theta. So children, here it is cot theta, but here it is 10 theta. Both are having 42 degrees. So if I'm reading this as cot theta 42, I'm taking as theta, then 10 42 degree will be read as theta only. Cot theta, same angles will be called by same symbol. So 10 theta is equal to cot theta, and here it is 10 theta. Cot, I will read this as cot theta. 42 I am reading as theta. Then this will also be read as theta. So cot theta into 10 theta, and this 10 theta can be written as 1 upon cot theta. So this is cot 42 degrees, this is cot theta, and this is 10 theta, which can be written as 1 upon cot 42 degrees. This and this will get cancelled. Similarly, this is cot 67 degree, and again the angle is same. So if I am reading this as cot theta, this will be read as 10 theta, and 10 theta is equal to 1 upon cot theta, and theta we have supposed as 67. So this and this will again cancel, and our answer will be this, which is equal to RHS, and hence proved. So this way we will proceed to solve the questions of this exercise. One more question for your understanding. So let's do question number 5. Question number 5. In question number 5, we have if sec 4a is equal to, if sec 4a is equal to cosec a minus 20 degree, we need to find out the value of a. Now, let's look at the question first. Here we are given sec theta, and here it is cosec theta. Now, children, we will change the style of writing sec theta. Just remember the formulas of complementary angles. Sec theta is always equal to cosec 90 minus theta. So applying the same here on left hand side, if I am reading this as theta, so this will become sec theta. Sec theta is equal to cosec 90 minus theta. So let's write down cosec 90 minus theta, and theta I've assumed to 4a, so I'll write 4a here, and this side I will copy down as it is cosec a minus 20. Now children, both the side same complement trigonometric ratio is there. This side also we have cosec, and this side also we have cosec. Whenever we have same trigonometric ratios both sides, if the trigonometric ratios are same, then angle attached to them are always equal if the theta lies between 0 to 90 degree. Until class 10th, the angle attached to trigonometric ratios will be from 0 to 90 only as per your syllabus. So cosec this side and cosec is this side. If both the trigonometric ratios are same, then the trigonometric angle attached to them, are always the same. So this implies, since the trigonometric ratio is same, this implies the angle attached to it will also be the same. 90 degree minus 4a is equal to a minus 20. Now we will solve for a. So bring this a this side, it will become 5a, and take this 20 this side. So this will become 110. Therefore, a is equal to 110 divided by 5. 5 twos are and 5 twos are. Therefore, a is equal to 22 degrees. So I hope you are able to understand how to apply the complementary angle formula and how to solve the questions. Let's do one more question of the exercise, that is question number 6. Question number 6, a very important question by examination point of view. Now this is one thing you have to notice, that in this question, first thing that is given to you, that A, B and C are the angles of a triangle, are angles of a triangle. And the second thing, they want you to prove that sine B plus C divided by 2 is equal to cos A by 2. Children, let's begin with the property of the angle sum property of the triangle. So you know, if these three are the angles of triangle, then A plus B plus C is equal to 180 degree. We need to find out the value of b plus c by 2. So let's take this a that side. So this is 180 degree minus a. Let's divide both the sides by 2. So divide both the side by 2. So children, this will become b plus c divided by 2 is equal to 90 degree minus a by 2. Now since these two angles are equal, these two angles are equal. If the angles are equal, children, if the angles are equal, see in the previous question, I said if the trigonometric ratios are same, the angles are equal. And if the angles are equal, that means if I take both the side, the same trigonometric ratios, they will become equal. So both the side I am taking sine, then even they will remain equal because both the side I am taking the same ratio, same trigonometric ratio, sine 90 minus a by 2. Children, if you are able to understand it like this, well and good. If you are not able to understand like this, let's suppose that this is 1 and I am putting the value of sine b plus c by 2 here. So sine b plus c by 2 will become, in place of b plus c by 2, I can write 90 minus a by 2. Now read this as theta, sine 90 minus theta. Now you are reading a by 2 as theta, sine 90 minus theta, and you did the trigonometric identity of complementary angle, that sine 90 minus theta is equal to cos theta. So sine 90 minus theta can be represented as cos theta, or theta is a by 2. Therefore, you got the answer. So I hope now you are able to apply complementary angles formula and can solve the questions related to it. That's all for today, children. Do a lot of practice and have mastery over this concept. All the best.